everything is altered. Documentation. So Algorand has provided us, of course, almost every platform has a documentation that will make developments easier and better for users or developers. Now, we have this documentation. Okay, Algorand has its own smart contract. Of course, we know that different platforms have their different smart contracts. Like on the Ethereum, we have Sdks. On Algorand, we have T. It stands for Transaction Execution Approval Language. So from the name itself, Transaction Approval Execution Language, we're talking about transactions, dealing with finances. So Algorand is a DeFi protocol, centralized finance, where you can use it to make transactions, financial transactions, things that do with money. Exactly. So we can build our applications using their protocol and then implement their payments gateway. We then use the word payments gateway to perform transactions on their network. Now, what we can do with Till, we can either approve a transaction or reject a transaction. So it doesn't give us that flexibility to build a DApp or a centralized application and it's in the Till itself. We can only approve or reject transactions if our conditions are met. That's if the balance is greater than that of the transaction fee, then if the account address that we're sending to or we're sending from is correct, all those validity checks will have to be done with you before a transaction can get approved. If any of them fails, then that transaction won't work. Alright, so we have SDKs. Of course, I didn't mention of the SDKs, so we can build our applications with our own preferred programming language and then integrate their payments gateway. So we can make use of JavaScript, Java, Python, Go, C#. They provided us with the SDKs for these languages, so we can use. You can also do that for making transactions. You can also use the command line. There's what we call Go command line to perform transactions. Just on your command line, you type some commands and then perform the transaction. Just going to So they have different networks. You can be on the testnet network to perform transactions on the building your application from scratch and then you want to test it to see if a functionality is working. You can do that. If you feel like okay, this is good enough, you can release it to the public to also test it for you, not just you. You can have the more tests, better. That's when you can launch it on the beta net. And if everything still works fine on the beta net, then you can move it to the main net. Now on the main net, unlike beta net and testnet, no real transactions, no real funds images of. But if you move to the main net, that's when you start doing with real transactions and real entities. Everything that we've done here so far has been on the testnet. So if I'm going here to the algo dispenser and then dispense funds into our account address, and the main net you can't do that. It's like giving out free money. So you can't do that. You need real money to do that. So that's how we can get to use the Algorand protocol to perform transactions. So that whole command line that I mentioned, they're all can be called a third party. You can use the Docker sandbox and then also create your own node or perform the transaction using the Go command line. Their sandbox, that's the Algorand sandbox itself. So you can see, I think I'll add one to the group chat and this thing will be sent. You can connect to your node also, so remember when we got our token and our server, and I said port is optional if you have port. So that is where we get to connect to a particular server or network on the Algorand. So you can see them with their various programming languages. We are doing Python. All you need to do is to install the Algorand package for Python. Then you import it from our SDK and then do this whole importation. You pass in your parameters, your Algo address, your Algo token, and then you make an instance of it right here as it was done, and then you can proceed with transactions. Okay, so yes, about generating account addresses, I made a demonstration with JavaScript. So if you're using it, if you have the JavaScript package installed, you can make use of this to import the package, Algorand SDK, and then to create an account, you're going to make use of the Algorand SDK. These are all built-in functions. Generate accounts, all these things are all built-in functions. So to generate an account, you make use of the Algorand SDK.generate account, and then we have a passphrase, that is our mnemonic key. Okay? So making use of Algorand SDK.secret to mnemonic key. That account that we created, remember every account has a mnemonic key, and every mnemonic key has an account address that is connected to it. So that is what we have here for this passphrase. Then we have console.log, printing my address in case of account.address, and then the passphrase, which was passed in here. So we can use this to print out the mnemonic key and the account address. Likewise, in Python, you can also follow the same procedures, or Java, or Go command line. That's if you're using that Go command line we talked about. You need to do something like this to the Go command line to generate your account address. And then adding funds, we demonstrated going into the testnet, that's the plan.testnet, to fund our account address on either the testnet or the betanet. But on the mainnet, that's where real transactions will be made, so you can't go to betanet or testnet and then fund it. So, and then I also made mention of where we can get our server and our token. So you can navigate to the kiosk, login, and then you can have your API key. And if you are running it on the testnet or betanet, but for the sake of this presentation, we run our transactions on the testnet. So we need this API key here, and then this for the server we need this name on the testnet, and then for the token we need this API key. Alright, so that is what we are going to pass in here. The server and then the token from the kiosk account that we generated before we can proceed. Okay, so on the Go command line, this is how we can perform transactions. Constructing the transaction. So we go to our parameters, like I demonstrated here. Let me go back to the code snippet. So we have our base server, we have our token, we have our Algorand, making use of the Algorand SDK to perform what we call instantiation. So what we mean by instantiation? We are going to create a new object that can have access to everything that is inside what we are trying to make instance of. Maybe it could be a method or a class. So if it's a class, you can have access to all the methods and their functionalities inside that class. That object can have. That is what this Algorand client, that's what we're doing with this Algorand client. And then below we have an asynchronous function that will help us perform this transaction. We have the constant declaration, params, making use of the Algorand clients. So now, like I said, this Algorand client is an object that we're making, a new object of this method. Now, when we just say Algorand client dot, you can see get transaction params. So let me make a very clear demonstration with that. Algorand client dot. So you can see a whole bunch of methods that we can call. Exactly. But then what we need is to get transaction params. So that's what we're doing here. Like things like getting current round that transaction will be, first round, last round, Genesis ID, Genesis hash. All those details are what we're going to get from here. And then below, we need our mnemonic key. Of course, if we are going to perform a transaction, every account address has its own mnemonic key. So we can also use a mnemonic key to get an account back in case you maybe lose our account address, but we have a mnemonic key. And of course, we are definitely going to have a mnemonic key stored in a secure place. So even if you lose access to our account address, you can use that mnemonic key to get the account address back. So that's what these two lines of code are doing. So we have mnemonic key, we have it here, and then recovered accounts. More like, let's say now we've lost our account address. So we have another declaration, recovered accounts, making use of the Algorand SDK, the mnemonic key to secret key, mnemonic to secret key rather, and then passing in the mnemonic. Now with this recovered account, we can use it to get our account address back. Alright? So we have another declaration here, transaction. We are passing in parameters. Now, of course, we're making a transaction. We need a sender, we need a receiver, we need amount, and all those details are going to be involved in it. So we have from, that is who we are sending from. Now, we're making use of the recovered account.address. We're calling the address that this mnemonic key belongs to. Then we have who we are sending to. This is an account address also, demonstrating or representing the address that we are sending to. Then we have a fee, a flat fee, 0.01 algos. Then we have the amount. Now, amounts are in micro algos, not algos. So you have to do that conversion. About 1 million micro algos is equal to 1 algo. 1 billion micro algos is equal to 100 algos. So here we have 1 million micro algos, which is equivalent to 1 algo. So that means during the course of this transaction, 1 algo will be sent from the sender, which is this recovered account address, to the receiver, which is this address. And then we are then passing in our params, the parameters that we declare transaction is going to do. So if every of the validity checks here, all of them are true and valid, then the transaction will be processed or made successfully. If there is one detail, for example, the account address not being correct, or something that, the account address is not correct, or this mnemonic key is not correct, that means we will also get the correct address that this recovered account belongs to. So all these details have to be checked and correct before our transaction can be approved. That is what the send transaction does. And then we have the sending of transactions. So once a transaction has been approved, or if a transaction is approved, then it will be sent to a particular block with those parameters as the first round, the last round, Genesis hash, Genesis ID, and the block ID that transaction belongs to. So all blocks are like storages. You can have up to 5, 6, 7 transactions belonging in a particular block. That depends on the time that block was created and the time the transactions were made that will go into that block to store the transaction information. So in the next 10, 20 years, you can come back, check that block ID. You'll still see the transactions that were stored inside of that block ID. You can still, inside of the block ID, you see the list of transactions and their IDs, that's the transaction ID. So you can look up a transaction in detail based on the transaction ID. So that's it for the sending of transaction. After we do that, we then have a console log to print out the transaction ID for us. So if you go to the Algo Explorer, okay, so if you go to the Algo Explorer, you can see a whole list of transactions that we've made, and then you can see the blocks that those transactions are belonging to, and the transaction ID that the block that transaction has. So you can look up a transaction based on the transaction ID, or you can look up the block, and then inside of the block, you can still make use of the transaction ID, and then you are able to see the details of that transaction. So you have other platforms have Sdks where you can build your own effect. You can build your own effect programming language instead of just depending on their smart contracts. I think that would actually make or provide that ease for a lot of developers, which is what Algorand is doing. So you don't have to go out of necessarily go out of your comfort zone to implement their protocol. You can make use of